Welcome dear audience, students and scholars. Here I am Dr. Amjad Ali. Dear scholars, so far as we have assembled a dynamic aggregate demand and aggregate supply model, and we used it to show how variance shocks affect the time paths of output, inflation and interest rates. We now use the model to shed light on the design of monetary policy. It is worth pausing at this point to consider what we mean by the phrase the design of monetary policy. So for this purpose, in this video we are going to discuss two applications lessons for monetary policy when we have a dynamic aggregate demand and aggregate supply model. Introduction. Dear scholars, so far in this analysis, the central bank has had a simple role. It merely had to adjust the money supply to ensure that the nominal interest rate hit the target level prescribed by the monetary policy rule. The two key parameters of that policy rule are theta pi, that represent the responsiveness of the target interest rate to inflation, and theta y, the responsiveness of the target interest rate to output. Okay, we have taken these parameters as a given without discussing how they are chosen. Now that we know how the model works, we can consider a deeper question which we are using to answer for the better understanding of the two application lessons for the monetary policy. That question is, what should the parameters of the monetary policy rule be? So for the answer of this question, let's discuss first the trade-off between output variability and inflation variability. Okay, consider the impact of a supply shock on output and inflation. According to the dynamic aggregate demand and aggregate supply model, the impact of this shock depends crucially on the slope of the dynamic aggregate demand curve. In particular, the slope of the dynamic aggregate demand (DAD) curve determines whether a supply shock has a large or a small impact on output and inflation. So for this purpose, let's see a graphical presentation here. Two possible responses to supply shocks. Here we have the two panel for the graphical presentation. The first panel is the related to the dynamic aggregate demand curve is flat. Here we have income output y on x-axis and inflation pi on y-axis, and we have a downward sloping dynamic aggregate demand curve that shows a flat demand curve, and we have a upward sloping dynamic aggregate supply curve. And we know that the intersection of the dynamic aggregate demand and supply curve will decide the equilibrium for the economy, where we have that level of national income or output and that level of inflation rate in the economy. So we have YT minus 1 output level in the economy, and with that level of inflation pi t minus 1. Okay, now a supply shock will shift the dynamic aggregate supply curve upward, that is DAST, and we have a new equilibrium at point B with a reduction, large reduction in output but small change in inflation. Let's see, we have that amount of change in inflation from pi t minus 1 to pi t, and we have a higher reduction in national output from yt minus 1 to T. So this is a large change in output. So when the dynamic aggregate demand curve is relatively flat, as we have described here, a supply shock has a small effect uh, on inflation but a large effect on output. Okay, moving towards the second panel of the graphical presentation, here we have the dynamic aggregate demand curve is steep. We have income output y on x-axis, inflation pi on y-axis. We have a steep dynamic aggregate demand curve, downward sloping, and we have a upward sloping dynamic aggregate supply curve, and the intersection of aggregate demand and aggregate supply will decide the national output, national level of income or output. We have here y t minus 1 with that level of inflation pi t minus 1. Okay, now a shock in the dynamic aggregate supply curve will shift the supply curve upward, and we have a new dynamic aggregate supply curve, and this will intersect the demand curve at point B. Now we have a large change in inflation from pi t minus 1 to pi t, and we have a small change in output from yt minus 1 to t. So when the aggregate dynamic demand curve is relatively steep, as we have shown here, the supply shock has a larger effect on inflation but a smaller effect on output. So here we have shown the slope of the dynamic aggregate demand curve is based on the parameters of the monetary policy that we have discussed, theta pi and theta y, which describe how much interest rate respond to change in inflation and output. When choosing these parameters, the central bank faces a trade-off between variability of inflation and the variability of the output. Okay, the overall graphical presentation in two panels shows that the first panel, the dynamic aggregate demand curve is nearly flat, so the shock is small effect on inflation, and it has a large effect on output. And when we have a dynamic aggregate demand curve steep, a shock in the aggregate supply curve has a larger effect on inflation but a smaller effect on output. So let's discuss another important question for the two possible response to this analysis. So here we have why is this important for monetary policy. Okay, because the central bank can influence the slope of the dynamic aggregate demand curve. Recall the equation for the dynamic aggregate demand curve. We have yt is equal to yt over bar minus into alpha theta pi over 1 plus alpha theta y into pi t minus pi t static plus into 1 over 1 plus alpha theta y, and the whole this part is divided by epsilon t. Okay, here we have two parameters, theta pi and theta y, which govern how much the central bank's interest rate target responds to changes in inflation and output. Okay, when the central bank chooses these policy parameters, it determines the slope of the dynamic aggregate demand curve and thus the economy's short-run response to supply shock. Okay, moving toward the further discussion about the trade-off between output variability and inflation variability. On the one hand, suppose that when setting the interest rate, the central bank responds strongly to inflation, and theta pi is large and weakly to output theta y is small. Okay, in this case, the coefficient on inflation is above equation is large. That is, a small change in inflation has a large effect on output. As a result, the dynamic aggregate demand curve is relatively flat, and supply shocks have large effects on output but small effects on inflation. Okay, the story goes like this. When the economy experiences a supply shock that pushes up inflation, the central bank's policy rule has its respond vigorously with higher interest rates. Okay, sharply higher interest rates significantly reduce the quantity of goods and services demanded, thereby leading to a large recession that deepens the inflationary impact of the shock, which was the purpose of the monetary policy response. Okay, moving towards the further discussion about the trade-off between output variability and inflation variability. On the other hand, suppose that when setting the interest rate, the central bank responds weakly to inflation, theta pi is small, but strongly to output theta y is large. Okay, in this case, the coefficient on inflation in the above equation is small, which means that even a large change in inflation has only a small effect on output. As a result, the dynamic aggregate demand curve is relatively steep, and supply shocks have small effects on output but large effects on inflation. Okay, the story is just the opposite as before we have discussed. No, when the economy experiences a supply shock that pushes up inflation, the central bank's policy rule has it respond with only slightly higher interest rates. This small policy response avoids a large recession but accommodates the inflationary shock. So, in this choice of monetary policy, the central bank determines which of these two scenarios will play out. That when setting the monetary policy parameters theta pi and theta y, the central bank chooses whether to make the economy look more like the economy which we have discussed here in the graphical presentation. When making this choice, the central bank faces a trade-off between output variability and inflation variability. The central bank has a hard line inflation fighter, as we have discussed in our graphical presentation of panel A, in which case inflation is stable but output is volatile. Alternatively, it is more accommodative in the panel B, in which case inflation is volatile but output is more stable. It can also choose some position in between these two extreme conditions. One job of a central bank is to promote economic stability. There are, however, various dimensions to this charge. When there are trade-offs to be made, the central bank has to determine what kind of stability to pursue. The dynamic aggregate demand and aggregate supply model shows that one fundamental trade-off is between the variability in inflation and the variability in output. Notice that this trade-off is very different from a simple trade-off between inflation and output. In the long run of this model, inflation goes its target and output goes grows to its natural level, consistent with the classical macroeconomic theory, policymakers do not face a long-run trade-off between inflation and output. Instead, they face a choice about which of these two measures of macroeconomic performance they want to stabilize. When deciding on the parameters of the monetary policy rule, they determine whether supply shocks lead to inflation variability, output variability, or some combinations of these two. Okay, moving towards the further understanding of the trade-off between inflation and inflation and variability of the output. Here we have the Taylor principle. Okay, one of the main questions which Taylor highlighted that how much should the nominal interest rate set by the central bank respond to changes in inflation. Okay, the dynamic aggregate demand and aggregate supply model does not give a definitive answer, but it does offer an important guideline. Okay, recall the equation for the monetary policy. Here we have IT is equal to pi t plus rho plus theta pi into pi t minus pi t static plus theta y into yt minus yt over bar. According to this equation, 1 percentage point increase in inflation pi t induces an increase in the nominal interest rate it of 1 plus theta pi, a percentage point, because we assume that the theta pi is greater than 0. Whenever inflation increases, the central bank raises the nominal interest rate by an even larger amount. Imagine, however, that the central bank behaved differently and instead increased the nominal interest rate by less than the increase in inflation. In this case, the monetary policy parameter theta pi would be less than 0. Okay, recall this change would profoundly alter the model, and we have recall that the dynamic aggregate demand equation as we have here yt is equal to yt over bar minus into we have alpha theta pi over 1 plus alpha theta y into pi t minus pi t static plus 1 over into 1 plus alpha theta y, and whole that part is multiplied with epsilon t. If theta pi is negative, then an increase in inflation would increase the quantity of output demanded, and the dynamic demand curve would be upward sloping. So let's see a graphical presentation, the importance of the Taylor principle. Here we have income output y on x-axis, inflation pi on y-axis. We have a vertical natural level of output, that is y over bar for all the time periods, and we have here an upward sloping dynamic aggregate demand curve, that is dAd t minus 1 or t plus 1, and we have a upward sloping dynamic aggregate supply curve as well, and this dynamic aggregate supply curve intersect the aggregate demand curve at this point, A point, and we have that level of national output yt minus 1 with that level of inflation. pi t minus 1. So this figure here till now shows the impact of demand shock in an economy that does not satisfy the Taylor principle. So the dynamic aggregate demand curve here is upward sloping. A demand shock moves the dynamic aggregate demand curve to the rightward for a period, one period. We have here DAD. Okay, and the economy moves from point A to point B, and we have a rise in inflation from pi t minus 1 to pi t, and we have a rise in national income from y t minus 1 to yt. So the increase in inflation at this point increases the expected inflation, and in the next period shift the aggregate supply curve upward. We have a new dynamic aggregate supply curve, that is DAS T plus 1. This aggregate supply curve will intersect the demand curve at point C. Okay, because the dynamic aggregate demand curve here is upward sloping, output is still above the natural level. So inflation continues to rise from this point to this point. Okay, in the second period, T plus 2, the economy moves to point D. So we have a new higher dynamic aggregate demand curve. This will intersect the dynamic aggregate demand curve at this point, and the economy moves from point C to point D, and we have a rise in inflation pi t plus 2, and we have a rise in output from yt plus 1 to yt plus 2. Okay, this part is considered the swirling inflation. So here this graphical presentation shows we have a upward sloping dynamic aggregate demand curve which leads to unstable inflation in the economy. Suppose that in period T there is one time positive shock in aggregate demand, which we have shown from this point, this curve to this curve, and that for one period only the dynamic aggregate demand curve shift to the right at DADT. So in the next period it returns to the original position. In period T, the economy moves from point A to point B. Output and inflation rises, as we have highlighted, from this point to this point, and inflation rises from this point to this point. Okay, output and inflation also rises the expected inflation in the economy. So the dynamic aggregate supply curve shift upward from this to this. This will provide the economy a new equilibrium from point B to point C with reduction in output but rise in inflation. Okay, but because we are assuming in this case that dynamic aggregate supply curve is upward sloping, output remains above the natural level, as we have that level of output is natural level of output, even though demand shock has disappeared. Thus inflation rises yet again, shifting the dynamic aggregate supply curve at this point, point D. So we have a rise in output from this point to this point, and we have a rise in inflation from this point to this point, and so on. Inflation continue to rise with no end in sight. Okay, moving towards the further explanation about the Taylor principle. Okay, the economic institution may be easier to understand than the geometry. A positive demand shock increases output and inflation. If the central bank does not increase the nominal interest rate sufficiently, the real interest rate falls. A low real interest rate increases the quantity of goods and services demanded. Higher output puts further upward pressure on inflation, which in turn lowers the real interest rate yet again. The result is inflation spiraling out of control. Okay, the dynamic aggregate demand and aggregate supply model leads a strong conclusion for inflation to be the stable. The central bank must respond to an increase in inflation with an even greater increase in the nominal interest rate. Okay, this conclusion is sometimes called the Taylor principle after economist John Taylor, who emphasized its importance in the design of monetary policy. Most of our analysis in this discussion assume that the Taylor principle holds. That is, we assume that theta pi is greater than 0. We can see now that there is a good reason for the central bank to adhere to this guideline. So this is all about the two applications lesson for the monetary policy when we are using the dynamic aggregate demand and aggregate supply model. So see you with another video. Ciao.